Morning to all. Now we are going to discuss about the topic Verilog models for multiplexers. We'll be going through these contents. First, we'll be seeing a small introduction about the multiplexers and how we can model a multiplexer using the concurrent statement and sequential statements. In sequential statements, we'll be using case statement and if else statement with always block to model. Okay. We all know that multiplexers are the combinational circuits, and as we stated before, we know for a multiplexer there will be 2 raised to n data input pins and n select pins and one single output pin. We can model this by using the concurrent statement only or using always statement. Okay, first we can see how we can design a model a 2x1 multiplexer using the assign statement. Okay, so first we are giving the inputs. We know that A 2x1 mux will be having 2 inputs, that is A and B, and the output is F. And we are giving the select pin as S. Okay, so the regular function F is equal to S bar A plus SD. So we can write the Verilog statement as the OR. No, not OR. The OR function of both S0 and A and S and B. S is ANDed with A. S is ANDed with B. That is ORed with S0 of S0 and A. Okay, so we can model the same by a conditional statement, that is assign F is equal to what's the condition of S. That is, if S is true, we can say that the output function will be B. And if S is false, we can say that the output function will be A. So the general form to write a assign function is that conditional function is that assign signal name, which is equal to the condition. Here the condition is whether S is true or false, and condition then the expression true. What should be the output if the expression is true, and then what should be the expression if the output is false. Here now we are using a 2 mux, and then we are using the conditional statement to get the to model this. Okay, so here we can see that we are having, this is our first mux, and here we are having the D, we are having D as our select pin, and in the second mux we are having E as our select pin, and F is the output. B and C are the inputs to the first mux. Okay, and here first we are checking, we'll be checking the condition whether E is, what is the condition of E, true or false. So first we are taking assign F is equal to, we are checking first E. E is true or false. If E is true, we'll be getting A as the output. And in case E is false, we'll be taking the first mux. Okay, the first mux we are giving the next condition whether D is true or false. That is, if E is false, we are going for the output or outputs of that first mux. And in the first mux, we are again checking the condition, that is whether D is true or false. If D is true, we'll be getting the output as B, and if true D is false, we'll be getting the output as C. Okay, now we are going for the 4x1 mux. In 4x1 mux, it is similar to 2x1. We will be having 4 inputs, 2 select pin and 1 output. So the Verilog function will be Sn F is equal to not function of A, not at A and not at B, and I0 will be ANDed, and that will be ORed with A bar B I1 or or that is the OR function, A B bar I2, then A B I3. This is the function that we'll be using. And for the condition, while we are using the conditional statement, we will be checking first what is the condition of A. If A is true, if in the case that A is true, then we'll be getting a condition. What's the condition of B? Okay. If A is true, we'll be next checking the condition B. Then the B is true, we'll be getting I3, and if B is false, we'll be getting I2. That is, if A and B are true, then we'll be getting I3, and if A is true and B is false, we'll be getting I2. And the next condition is that the A is false. If A is false and B is true, we'll be getting I1, and if A is true, A is false and B is false, we'll be getting I0 as the output. Okay, next we are going for a sequential statement. In sequential statement, first we are taking the case statement. Okay, so the general form of that case statement is the first what's the case expression that should be given, and then the choice. First choice, that is choice 1 and the sequential statement 1, then second choice, then the sequential statement 2, and if there are 2 or 3, then it will be here, and then we should end our case. So we can see one example, like for the mux we are using the 4 cross 1 mux, and we are representing SEL cell for the selection signal, and we'll be representing it as the number of bit is 2, binary for B, and 0, 0, 0, 1, 1, 0, and 1, 1, each pins. Okay, the value of each. Then we'll be going as always at cell, that is the select signal, select pin, I0, I1, I2, and I3. Those are the input pins. And case, our case is the selection signal. So say case cell 2 bar B00. That is the first choice. Then our sequential statement will be, first sequential statement will be F is equal to I0, I0. Then the second one, the sequential statement is F is equal to I1, then I2 and I3. And then we are ending a case here. Okay, this is how we will be modeling the mux using a case statement. Next, we are going to see how we'll be using the sequential statement using if-else statement with always block to design a 4 cross 1 mux. Here it is same, always at cell or I0 or I1 or I2 or I3. And then we are beginning this function, always block. Then first we are saying that if cell is equal to 2 bar B00, then the function will be I0. If this is wrong or this is false, then we'll be get else if cell is equal to 2 bar B01, then our functional statement F is equal to I1. If this is also false, then we'll be going for the next else if conditions, and then finally we'll be ending our function. Okay, thank you.